I just want to discuss with us how we can produce sine wave inverter. We have different type of inverter. We have modified sine wave, we have pure sine wave, and we have square wave inverter. So out of these three type of inverter, pure sine wave inverter is the best. And one of the way by which we can produce pure sine wave inverter is with the help of a transformer. These are the materials we need. We need a transformer. This is a transformer. Then we need a MOSFET board. This is a MOSFET board. Then we need the control card. This is a control card. Then we need the capacitor to filter out. Then at times you may use a display. But at times you may not use a display. But these three components, the capacitor here, the control card, the control board, the transformer, and then the MOSFET board are very important. Without these components, you can't produce a pure sine wave inverter I'm trying to discuss today. The first thing is to get a transformer. This is a transformer, and these two terminal, the two terminal here is the primary for a transformer. This is the primary, so this will be the secondary. Then this third one, this is the auxiliary terminal. But the main terminal we need, is this primary, these two primary terminal. Then this is secondary. So this inverter I want to produce is for 12-volt single battery system. So 12 volts. The first thing to test this transformer when you get it, because this transformer I want to use it to design a 12-volt pure sine wave inverter for a single battery 12-volt system. So I want to connect it to power supply now. So let me connect this thing to power supply, the transformer to the power supply. I want to measure the input voltage now. I supply to this transformer. Take note of this. So you can see it clearly now. This 230 volts AC. Then you now measure the primary. I've measured the secondary now. This is the input. I've measured the input. That's 230. I want to test. This is the output here. Now place it here. You can see that it's 7.3. So for a 12-volt system, this terminal must be within a range of like 5.5 to 8.5. So for a 12-volt single battery system, for a 12-volt, so that's the first thing to do to test your transformer if it is okay. I told you earlier on that we need a control card, a MOSFET board. This is a MOSFET board. If you look at it clearly from here now, this is a MOSFET board. These are 4 MOSFETs. You can see 4 here, 1, 2, 3, 4. This 4 and another 4 here. Then this heatsink is separated. It's not joined together. Then this the other side of the board now. This is the other side of the board. We have another 4 by 4, making this 8, and this side another 8 MOSFET. This 8 MOSFET here. Then this side is another 8 MOSFET. This is the MOSFET board. This is the board that will carry the load. The capacity of this MOSFET board in conjunction with this transformer determine the capacity of your inverter. Then another important board is this control board. This control board communicates with this MOSFET board. It gives the appropriate signal to this MOSFET board. Negative terminal of the battery will be collected here, while the positive terminal of the battery will be collected here. So that's how it works. So now let's start now. This is our negative terminal. So I've collected the negative terminal. Then this is the positive terminal. I want to collect the positive terminal. I want to screw the board to the cabinet so that it will be stable.
Then this primary terminal now, we connect it to the heatsink. These are two heatsink. Let me show it very well. You know, this one heatsink, this another heatsink, this is the third heatsink. This third heatsink, we have connected it to the positive terminal of the battery. Then this heatsink and this heatsink we connected to the primary of the transformer, primary terminal of the transformer. So let's try this now. So now we have connected the primary terminal of the transformer to the heatsink now. So we now need the control board. This control board needs a cable to communicate with this MOSFET board. So we have connected the control board now with the MOSFET board with the help of this white cable. So the control board will send the appropriate signal to this MOSFET board to drive this transformer. Then that's why you cannot generate a pure sine wave signal out. This component attached to the heatsink is a thermistor. You have to collect all the necessary components now. This is a thermistor that measures the temperature so that it prevents overheating. Then here now, this is the switch, this is on and off. Then this is the fan. This is the fan, cooling fan. This is the fan. So we collect it here. Then this is auxiliary supply from the transformer. We collect it here. Sorry, from the transformer we collect it here. Then we begin to solder. This is the terminal now for the transformer. This is the output terminal. So then another thing is this capacitor, we have to solder it because it's a filtering capacitor. It filters out the high frequency generated. So this bulb will generate high frequency signal. So this capacitor will help us remove it from the output before being supplied to the electrical appliances connected to it. So we are collecting this capacitor at this terminal here, this output port. We want to collect this capacitor here. So we have soldered the output capacitor. Then we need to solder all this cable. Now this is the neutral wire. So we have to solder the live wire here. That's the transformer. So now this is the wire supplying to the output socket. This is the wire that we supply to the output socket. This is the neutral wire of the output socket. Now this additional wire is the power supply from the main, assuming because this inverter needs to charge with power supply. Apart from solar, it can use electricity from mains to charge. So this is the input from main, from NEPA, to charge the battery. When there is light, and to also bypass. Bypass. So we have collected. We need the start button here. So we now collect the start button here. Then if you want to use display, collect the display here. So we can collect the display here. Let's try and test. So now we have collected everything together: the transformer, the MOSFET board, the control board. So let's see now and collect it to the power supply. So let me test my power supply. This is my power supply footage. This is my power supply. So now I want to collect it to 12-volt power supply now. So collect it to my power supply. The display will come up. So now I will now collect it to the input. Let's see. So this is the output now. Output footage 236 foot. That's the output footage now. So we have produced a sine wave inverter. Let's collect an oscilloscope and see the type of wave we are producing now. So let me switch to oscilloscope mode. So we can now see this is sine wave inverter. This is a pure sine wave inverter. So to produce sine wave inverter is very easy and straightforward. Very easy and straightforward. Thank you.